population standard deviation is denoted by sigma. For example, sigma x, standard deviation of x is equal to under root of summation xi minus x bar square divided by n, number of observation, and standard deviation of sample is denoted by small s of x is equal to under root of summation xi minus x bar divided by square divided by n minus 1, total number of observation minus 1. And now variance. Variance is what? When variable vary from its mean. So population variance is denoted by standard deviation of x square of standard deviation. So summation of xi minus x bar square divided by n, and the sample variance small s square is equal to summation of xi minus x bar square divided by n minus 1. Now the covariance. When two variables change simultaneously, so covariance of xy is equal to one upon n summation I is equal to 1 to total number of observation xi minus x bar and yi minus y bar. Here we are not taking deviation, square of deviation, because we are here we want to see the directional change between two variables. If we square its deviation, then we get only positive relations between two variables. That's why we are ignoring here square of deviation. It is about population covariance, and now we will see covariance of sample x y is equal to 1 upon n minus 1 summation I is equal to 1 to n number of observation summation xi minus x bar into yi minus y bar. Now we will talk about correlation. denoted by R of xy is equal to covariance of xy divided by standard deviation of x and standard multiply by standard deviation of y, and same formula for the sample correlation or covariance of xy divided by standard deviation of x multiplied by standard deviation of y. Here we will simplify it. Sorry, let me change the color. Or xy is equal to covariance of xy divided by standard deviation of x into standard deviation of y. Let me simplify here it. uh, Correlation of xy is equal to covariance. Covariance is what? Here it is 1 upon n summation I is equal to 1 to n number of observation xi minus x bar multiply by yi minus y bar divide by standard deviation of x multiply by standard deviation of y. So standard deviation of x is equal to summation xi minus x bar square divided by n multiply by summation yi minus y bar square under root n, and same for the sample correlation. Xy is equal to covariance of xy, so 1 upon n minus 1 summation I is equal to 1 to n number of observation xi minus x bar multiply by yi minus y bar divide by standard deviation of x summation xi minus x bar square divided by n minus 1 multiply by standard deviation of y summation xi minus x bar square divided by n minus 1. Now we can further simplify it. R is equal to r xy is equal to 1 upon n. So here we remove the 1 because it cannot affect our formula. So summation xi minus x bar multiply by yi minus y bar. We can write it as and multiply this one and this here. Now standard deviation of x summation xi minus x bar square divided by n into, we can elaborate the same in the root. So summation yi minus y bar square divided by in the root divided by n. Same for the sample correlation, or xy is equal to summation xi minus x bar mm, multiplied by yi minus y bar divided by this n minus 1 multiplied by standard deviation of x summation xi minus x bar square divided by n minus 1, and we expand this under root summation, sorry, oh, it's y here, not x bar, y bar yi minus y bar summation yi minus y bar square divided by n minus 1. So if we take it out from the under root, r is xy is equal to summation, we can write xi minus x bar is equal to small x and yi minus y bar is equal to small y divided by n. And if we solve the under root section, summation xi into summation y square divided by n into n. Same with the sample correlation, summation small x into small y divided by n minus 1 into multiply by summation xi, sorry, x square. Why we are taking square? Because in the above here is square, so 1 multiply by summation y square divided by n minus 1 into n minus 1. If we take it out from the root, so r is xy is equal to summation small xy divided by n into, if we take out of under root this, it will be n 1 by n, and left out only summation x square into summation y square. Same in the case of sample correlation, summation xy divided by n minus 1. If we take these values out of the under root, then it will give us one value, n minus 1 multiply by under root summation x square into summation y square. How it will run? So for example, 2 is equal to 2 under root 2, now 2 square, which is equal to 4, is equal to 4 under root into 4 under, or we can say under root 4 into 4, or we can say under root 16. If we take Out of it, from under root we get 4 or 2 square. Here two values of 4 is equal to, out of the under root is single value of 4. Okay, I hope it is clear now. So here we can cancel out n by n, or n minus 1 divided by n minus 1. Now xy is equal to summation small xy divided by summation x square into summation y square. Same with the sample, or x is equal to summation xy divided by under root summation x square into summation y square. It's both sample correlation or population correlation, both are equal. I hope it's clear now.